Welcoming you all my lecture series of operating system. In this lecture, we are going to explain about case study on page replacement. So before going to explain our student the case study, I will tell about what is a page replacement, why we need the page replacement. So the page replacement is a memory management technique is used by the operating system to decide which page should be used stored in the physical memory. So why we need the page replacement means the operating system checks the page in the page table if the using that valid or invalid bit. If the page is not in the page table means it brings that page from the secondary memory to the physical memory. So at the time of swap in from that secondary to physical memory, it checks whether there is a space for that page or not. If the page is not there is no space for storing that page means we have to replace the currently physical memory page. So and we have to swap out the current page and swap in the needed page. So that is a concept in the page replacement. That figure is shown in the right side. That concept is shown in the right side figure. So the operating system checks the page table. If the page table is not pages is not in the page table means it find that page in the secondary memory and is page out the victim page and page in the desired page. That is a concept in the page replacement. Students, I will ask one questions about, can you explain how the page replacement is used to do the efficient memory management in the in our system? So anyone can explain that?
Hello all. Today we are going to discuss about the case study on page replacement algorithm and memory allocation techniques. First of all, what is paging? Paging is a method used to split an logical memory, that is virtual memory, into small segments of equal amount of spaces to store and process into a small segments. The pages will be stored in the frames. The frames are nothing but it is also an segments which are small blocks of physical memory, that is main memory. The page will be stored in that framework and it will be accessed by the CPU. There will be a page table in between the page and also frame. It consists of two segments, two contents, that is page number and frame number. The page consists of process data and offset, and the frame also consists of process and offset. The offset will be same for the both frames and pages. The frame size and also an page size will be an equal. About the working flow of the paging. Before getting into it, first let's see what is page and frame. So page is represented as the logical representation of the data, and the frame is explained as the physical representation of the data. Here you can see that the both frame number and page number would be different, but if you see both the offset values will be same. So first the user will be explaining an input on getting the page. If the page is present in the page table, then the page will be directly accessed and then given as an output. If the page is not present in the page table, then the CPU would be sending an interrupt to the secondary memory. From the secondary memory, the page will be replaced with the another page that is present in the page table. If there is enough amount of memory that is present in the page table, then it will be directly allocated into the page table. If the page table is not having enough amount of memory, then here the page replacement technique will be coming in. So we will be explaining about the different types of page replacement techniques like FIFO, LRU. FIFO stands for first in, first out, and LRU stands for least recently used, and also about the optimal binary search tree in the upcoming case study. So as I was saying, if the page table is not having enough amount of memory, then the page replacement technique will be coming in. After that, the page replacement technique, the page will be replaced into the page table and then it would be accessed. Going to discuss about the page replacement algorithm. First is FIFO, first in, first out. In first in, first out, there will be frames like let's take an example. There will be 6 frames and n number of processes. The process will be entered in the frame and will be accessed by the CPU.
there are more than a 10 process or 12 process like that. Already there has been six process. The seventh process need to be accessed by the CPU, so that the first process which will be entered into the frame will be popped out from the frame, and the seventh process will be popped into the frame. Then it will be accessed by the CPU. There will be a hit ratio and also a fault ratio. Whenever there will be a five process in a frame. I am going to access about the fourth process. So it will be already present in the frame. So it will be an hit. Hit me if there is process not present in the frame, there will be a fault. Whenever the hit ratio is an high, the algorithm will be an efficient. Whenever a fault ratio is high, the algorithm will not be efficient. Next is OBST, which is optimal binary search tree. Optimal binary search tree is like an future prediction. Whenever we need to access and process which is not all present in the frame, we need to check whether we need to check how long it will be take to the access the process again. Whenever a process some process need to be accessed after a long time, that kind of process will be replaced with the new process. The first process will be accessed at the end of the whole process. It will be replaced with the current process. Then it will be accessed by the CPU. Like that, FIFO, it will be more efficient than the FIFO.
Now I am explain about LRU. What is LRU? LRU stands for least recently used. In operating system, the CPU always needs data to work with it. Data is usually stored in memory, but memory is limited. So when it gets full and new data is needed, the operating system must decide which data to remove. Real life example of LRU. Imagine you have a small bag that holds only 4 books. You are preparing for exam and you keep taking books in out of your bag. If your bag is full and you need to put a new book, and you will remove one book you have not read in a long time, right? How LRU works in operating system. Memory is divided into frame like books slots. Data is brought into memory units called pages. When page is needed, it is already in. Advantages of LRU. It's logical and human-like, perform well in many real-world applications, predictable and simple to implement using data structure like stacks or queue. Limitations. Need to keep track of usage time, requires extra memory or tracking. Slightly expensive in terms of performance compared to the simple algorithm.
About the different types of memory allocation techniques, there are three types of memory allocation techniques. The first one is worst fit, second one is first fit, and the third one is best fit. Now I am going to be explaining about the worst fit. So worst fit is a type of algorithm in which there are going to be processes which are going to be allocated to the highest memory allocation. If you see, even though there is a small process that is there, it is going to be allocated to the highest memory space that is available. So because of which the amount of memory efficiency is going to be less and deadlock situations may also occur. So the worst fit algorithm is said to be really inefficient when compared to the other two types of algorithm techniques, that is the first fit and the best fit.
This first fit. In first fit algorithm, the process will be allocated to the first memory which is present in the memory space. But in best fit, the process will be allocated to the smallest memory space which will be present in the memory space, so that the largest memory space will be remains for the other process. So it will be an efficient algorithm. Comparing to the three memory allocation algorithm, best fit algorithm will be more efficient, and it will be used to avoid the deadlock situation, so that every process will be accessed and processed efficiently, so that no process will be left without being processed.